Okay, so the bear said to the other bear, oh, wait, I'm sorry, video's on. Anyway, back to the video. All right, let's look at this guy. It looks kind of rough, looks kind of mean, but he's not. This is not a product rule. This is, two is not a function that we would call a product rule type of question. Let's face it, y equals 2. That's a pretty easy graph right there. So slope of 0. Anyway, so this is not a product rule. So just like we wouldn't do a product rule on 2x cubed, we're not going to do a product rule here. It's going to treat this is the same as 2x cubed, 6x squared. This will be done the exact same way over here. So we will write this as 2 tangent x cubed, and we'll treat it just like it was this guy. So here we go. If you're ready, it's just a chain rule. So 3 times 2 is 6. Tangent x 3, and we would do what? Subtract 1. So we're left with square times now the derivative of tangent, which is secant square x, and that's it. Well, theoretically, times the derivative of x, which is 1. So my answer is just 6 tangent square x secant square x. And that is my answer. And I'm done at this point. So anyway, that one's not too hard. Let's move on and do this guy. Let's see if he's hard. Same thing, don't let the 2 mess you up. The derivative of 2e is going to be this. Oh, I love it. 2e 1 minus x squared times the derivative of 1 minus x squared. 1 minus x squared, the derivative of all that is just what? Times negative 2x. So my answer is negative 4x e 1 minus x squared, and that is my answer at this point. So anyway, so far, so good. All right. Keep going. I'm having a ball. All right, so we got the log cosine. Again, this one's not a not a product rule or quotient rule or anything. It's just a plain chain rule. So what's the derivative? If I had log of 2x, what would I do? It'd be 1 over 2x times the derivative of 2x, which would just be 2. This one is no harder. When I get ready to do it, it's just 1 over cosine 3x squared times the derivative of cosine 3x squared, which would be negative sine 3x squared, times the derivative of 3x squared, which would be 6x. So here is my answer on this one. So anyway, let's see what we can do here. Fix this guy up. So we end up with 6x, negative 6x, sine 3x squared over cosine 3x squared, which you should immediately notice this simplifies. Now, please make sure you notice something. This square that we keep talking about, this square is on the x up here. It's not anything to do with the sine or the cosine. So theoretically, I mean, what we've got is this is what's going on. So the answer then we can simplify to negative 6x tangent 3x squared. And here is my derivative of that one. So that one turns out kind of neat, the way it goes. Keep going, we'll finish this up. Next one, the derivative would be 5e sine 3x times the derivative of sine 3x, which would be cosine 3x, times the derivative of 3x, which would just be 3. So the answer ends up 15 cosine 3x e sine 3x. There, that would be my first derivative of that one. All right. So, bam, this is not bad at all. I'm totally loving this, is what you're saying right now. This guy, all right. First of all, we could do 2 different things here. One, we could split him up, and we could work this problem in 2 parts, just like this. And we could work it out completely separate from each other. Or you could just remember something. Hey, sine square plus cosine square. That's a trig identity. Wait a second. That's 1, which means y prime is, oh my goodness, tricky, tricky, tricky. You believe that? Trying to make me think I had a hard problem. All right, next one that we got up here. Wait a second. Right off the bat, I could do the same thing. I could split this guy up and do secant x square and then do tangent x square. Hey, I could go this route. But you know, I'm starting to get this little memory thing here. Didn't we have a trig identity that says secant square equals tangent square plus 1? So let's try and substitute this identity in first. So tangent square x plus 1 minus tangent square x. Oh my goodness. So that means that this is 1. So, oh my goodness. I can't stand these tricky little questions like this. Oh, how did they dare slip that in on me? Oh, well, what about this guy? Cosine of x to the half. Well, he's just a chain rule. What's the derivative of cosine? Negative sine x to the half times the derivative of x to the half, which would be 1/2 x to the negative half. All right. Now we need to clean this guy up a little. So what's he going to look like? So this is negative sine of square root x over 2 square root x. So there is my answer to you, good sir. Oh my goodness, we are on absolute fire at this point. Derivative taking machine. Matter of fact, we may be about done. Any second we'll tap and there's going to be no more problems to do. This guy up here, let's see if we can do him. He would be tangent of x4 cubed. And it's just a chain rule question. So all we're going to do is 3 tangent x to the 4. 3 would become square times the derivative of tangent is secant square x to the 4 times the derivative of x to the 4 itself, which would be 4x cubed. So, woo, this guy is not going to be cute, but that's all right. My answer would be 12x to the, what we got, third tangent square x to the 4 secant square x to the 4. And yeah, I could try and plug in some kind of identity here, but it would not simplify this guy. It would only make it uglier to try and do an identity. If this looks confusing, you could try and put your x to the 4 in a parenthesis or something, but still done. Uh-oh, now wait a second. The second I see this is not the sign of cosine. These are two completely different functions being multiplied times each other, which tells me this is a product rule question. So u prime would be, let's see if I can do this. U prime would be cosine x. That's easy enough. V prime would be, 2 cosine x times the derivative of cosine x, which would be sine x, which, hey, that's an identity. That becomes sine 2x. So let's do our product rule. U prime v plus u v prime. So u prime is cosine x times v, which is cosine square x, plus u, which is sine x times sine of 2x. And blah, blah, blah. Let's see what we can't do. And I'm going to call this cosine cubed x plus sine x sine 2x. And if you're looking at this, trying to see if this condenses or, simplifies, nah, just strap my answer around this. Because these are two, if you're trying to simplify, see, that's sine of x and that one's sine of 2x. So I can't, it's not the same thing. They're not the same value. So I can't just multiply them times each other. So that's going to be my answer. And turns out I got one more. Look at this guy. I thought I was done. Cotangent of t. Well, first thing I do is look at this, and what my eyes see, I see two functions being divided, which tells me I'm going to be doing this. I'm going to be doing a quotient rule here. So I'm going to throw that out over here. So let's see what we can do. Let's see, u would be cotangent of t. See, the derivative of cotangent is negative cosecant square t is what we'd end up with. All right. And then the derivative of my v term would be e to the t times derivative of t, which would be 1. So it's just e to the t. And so now I wonder if I made this one up or it come out of a book, because this thing's hideous looking. Negative cosecant square t times v, which is e to the t minus u, which is cotangent t, oh goodness, times v prime, which is e to the t, over v square, e to the t square. Good night. This thing looks, who come up with this one? This thing is beyond ugly. Oh, wait a second, though. I see something cool. See, it's e to the t square on bottom. Check it out. That's the same on bottom as et, right? Oops, I just drew a gigantic T. Et. Wait a second. Oh my goodness, check it out. Oh, snap. So we've got negative cosecant square t minus cotangent of t. I do little parentheses there because of the t on the end of cotangent over et. If you're thinking, could we do some type of derivative there? I mean, some type of identity. We could. Cosecant square is cotangent square plus 1, but that's not going to simplify this any because of the little square that's on there. So anyway, I'm going to go ahead and I'm going to strap a box on this one. That is my derivative. Oh, excuse me. In this case, it should have been f prime t. But anyway, and with that, I close this video and bid you good night. Bye.